All right. So don't work ahead. Just stay with me. This is not going to be homework. This is kind of laying the foundation for this unit and even kind of a little bit in the next unit. So having a good understanding of distance and displacement are just going to set things up to make it a lot easier for you as we go forward. So what I would like you to do, hopefully my pen is right. Oh, yes. Fine. So I want you to put at the top this little P. So make a little dashed line, and then this is going to mean that delta means change in position. I think I need to calibrate here. So mark that and do a quick calibration. So the little triangle means equals, so those dashed lines put equal, change in position. So that triangle in position. Okay? And so the other thing I want you to write at the top of your paper is XF, with that little subscript F, is your final position. And XI is your initial. And remember, final could be worded like the end, it could be, if you actually say final, initial might be beginning, might be starts, final I guess could also mean end. Okay. So if you see any of those words like in the problems, like those are the things that you're supposed to be, like it'll kind of help trigger, oh, okay, that's my final, that's my initial. If you hear end, begin, start, you know, those kind of similar words or help trigger that. All right, we're going to use like dots to kind of show where we're starting, and then arrows to describe and show the motion. All right, so it says, Tasia walks 2 miles north from her door to the park, then returns home to her door. So if she starts right here and walks 2 miles north, I'm going to draw an arrow straight north, so make sure you're doing what I'm doing. 2 miles north, and then it says, then returns home to her door. So the repeat journey puts her back there, another 2 miles. So we're going to, and I'm just gonna, this isn't like a true abbreviation, but I'm lazy. So that's gonna be my distance, and then DSP, DISP, I guess, is displacement. If you wanna write out distance and displacement, you're more than welcome to, but DT for distance, DISP for displacement. So distance is all about the entire pathway. So she walked 2 miles, turned around, 2 miles back. What would her distance be there? What do you think, Garrett?
4 miles.
Tell me 4 miles. MI is the abbreviation for miles. M is the abbreviation for meter. So make sure you put MI if you want to abbreviate. Now, what is Tasia's displacement going to be? Why is it 0? Okay, so she started right there, right? She ended right there. It's kind of like that dog example. He got up from his bed, walked 5 meters, turned around, walked 5 meters back to the bed, went back to sleep. Displacement is all about where did you stop and where did you end. Same spot. Tasia didn't go anywhere according to displacement. She actually traveled a total of 4 miles, but displacement was 0. Distance, 4 miles. So in an example like this, distance and displacement are different values. Okay? Do I need to include a direction if it's 0? I wouldn't even know what direction that would be. So that's the only time you don't have to include a direction is if your displacement ends up being 0. Do I need a direction for distance?
No.
Nope. It is scalar, meaning no directions needed. So Amy runs 2 miles south, then turns around and runs 3 miles north. So, right, 2 miles south. Hold on, I might want to make that a little bit shorter. Do this, sorry. So 2 miles south, turns around and goes 3 miles north. Notice how these arrows have, they're not just lines, they're actual arrows, right? They are showing the direction of the motion. So this is my beginning position. This is my final position. Now, is this exactly to scale? No. Does it need to be? No. These arrows are just kind of to help you kind of visualize the motion, right? So, what is, and I'm going to put it kind of over here, I guess. I'm playing ahead great with my spacing. So, what is going to be the distance that Amy ran? Good. 2 miles, and then you add 3 more to it. So distance is kind of like, in a way, is this miles? Yes. Kind of like perimeter. Like you're just following the whole path, whatever it may be. All right? Adding everything up. What is the displacement going to be? What do you think, Andy?
1 mile.
Okay, so it's going to be 1 mile. Now here comes the trickier part. What direction? Well, if you look at where you start, right? Look at your final location. It is north of where she started. So you can either write it out, you can put a capital N and like brackets. The only thing that sometimes can get confusing is that capital N is also the abbreviation for Newton, which is the unit for force. We haven't gotten to that yet, so we're really not going to be using it in this unit. But just understand, a lot of times they will put the capital N or directions in a bracket like that just to help signify that's a direction. If you want to just put the word north, you're welcome to write it out. But I need something, obviously, that's going to show the direction. So making this vector, I have the magnitude, I have the unit, and I'm including a direction, okay? One way I like to do it is if I put my, like the end of my pen or like my pencil at the starting location and I point it in the direction that I ended, the direction that my pen is pointing is going to match the direction that you need to use. And so this one's kind of easy. You can obviously see that it's north of your original location, but some of them are not as easy if they start to make turns. You're like, okay, well, it went this way, and then it went this way, and then it went this way, so which way did I go, right? And so if you put your pen on the XI and they point it towards where you finished, that will give you your direction. Good? All right, so really, this right here, that's where this dotted line comes in. This is my change in position, right? From the 2 to the 3. All right, so let's look at number 3. So before I forget, I'm going to leave myself room because I'm still doing distance and displacement for all of these. And so Jermaine runs exactly 2 laps around a 400-meter track. So let's say this is where I start, right? There's 1 lap and there's 2 laps. A little messy. And Jermaine ends right there. How far, what was his total distance, Billy?
800 meters.
Okay. All right. What is the displacement going to be, Brookston?
0.
Good, because your XI and your XF are the same. So anytime that's the case, you have 0 as your displacement, which is really good because in a circle, you have actually faced every single direction, right? So it'd be harder to kind of come up with the direction. And so if it seems really confusing with direction, there's a chance that maybe your displacement is 0, and that's why, because it, direction is going to be kind of really hard to figure out because you didn't have a displacement. It was 0. All right, so Ray runs 30 feet north, 30 feet west, and 30 feet south. So I'm gonna, maybe not starting there again, hold on. Land this one ahead. There. Oh, I'm sorry, it was north. Never mind, it was right. Okay, so gonna go 30 north. My next direction says 30 feet west. And then it says 30 feet south. Now, because it's 30, 30, 30, I'm trying to make my lines, my arrows, the exact same length. Is it perfect? No, but it's okay. Like, you're trying to keep it reasonable. So this is the beginning location, my XI. This is my XF. Are they the same spot? No. So there is going to be a displacement. So let's start with the easier one. Again, distance is kind of like perimeter. You're just adding everything up for the whole path. So Echo, what is going to be the distance that Ray ran? 90. Good. And what are going to be the units that I need to include? What are the units given in this problem? Perfect. 90 feet. Now, here's where that little dashed line comes in, because displacement is where you started to where you finished. So I'm going to only look at that dashed line. I don't care about the pathway. I just want to know how far did this person go start to finish?
30 or 30 feet.
Okay, so you say 30 feet, and so I love the direction in which you're correct. Here's another way you can do it. If you put your pencil on the beginning, point it to where you end. What direction am I pointing? Pointing west, and that's going to give me my direction. Okay? And I know it's 30 because this is 30. Right? Any question on that one? Okay, so Alex walks east for 3 kilometers, stops for a break, and runs the same direction for 4 more kilometers before he stops. So, let's do our DT and our DISP. So, 3 kilometers, takes a little break, and then goes 4 more. Right? What is going to be the distance here, Kenna? Good. And what are the units going to be? Good. All right, so this is my XI. This is my XF. So displacement is beginning location straight to my finish location. So Kendall, what do you think? It's also going to be 7, and it's going to be kilometers, and in what direction? Yeah, east. So again, our little trick, put your pencil end on the initial, point it to the final. The direction that my pen is pointing is, sorry, it's messy, east. So, we've had an example of where displacement will be 0. The other example is where distance and displacement are going to be the same. If you go in a straight line and don't make any turns, you just go straight, distance and displacement will be the same. Just like that ant yesterday at 10 centimeters going to 50 centimeters, it just walked a straight path. Never turned, never went back, just stayed on that path. Distance and displacement will be the same every single time. So that's one kind of like key thing to keep in mind. The other is if you start and stop in the same place, displacement's always 0. So there's some firm, hard, nice, easy, kind of, go-to answers that should start popping out at you. Start and stop in the same spot, displacement 0. If you just go in a straight line with no twists or turns at all, distance and displacement will be equal. Okay? The only thing is you do still have to include to put the direction for the displacement. Any questions so far? Is that okay? All right. Oh, let's look at these last two. All right, so Taylor rides her bike 20 kilometers north, turns around, then rides her bike 15 kilometers back towards her starting point. Starting point, 20 kilometers north, turns around and heads back 15. This is my XF. So what is going to be my distance, Gilbert?
Distance would be 35.
Very nice, good mental math. 35, what are the units going to be for this?
North.
That's the direction. Was it miles, feet?
Kilometers.
Good, that's my unit. Good. So when we're looking at displacement, remember, we only care about our initial to our final. That little space. So what's that gonna be? What do you think, Ethan?
5 kilometers.
Okay, 5 kilometers. And my little trick is put it where I start, point to where I finish, and it's pointing north. Good? All right, here's the last one. It's the trickiest. I'm gonna pull in some old math. So Derek crawls 4 feet south. Okay, I just want to make sure I was leaving myself enough room. So I'm going 4 feet south, and then crawls 6 feet east. Okay? What is Derek's distance going to be? Brooklyn, what do you think? What is his distance from my initial to final? But for distance, we want just the pathway, right?
Yeah, 10 feet.
Good. 10 feet. Very nice. Displacement's going to be, well, Brooks got it. We're looking at xi to xf.
That's over that Pythagorean theorem.
There we go. Pythagorean theorem, which is what?
4 squared plus 6 squared equals c squared.
Okay, so our theorem is a squared plus b squared equals c squared, where this is a right triangle. Short two sides squared added together equals, so if this is my A, this is my B, my hypotenuse or my longer side is C squared. So he said if we put in 4 squared plus 6 squared, that should give me my C squared. And so 16 plus 36 is what?
52.
Okay. And then we don't want C squared, we want that displacement just by itself. So somebody have a calculator, square root of 52?
I'd say that's about 21.
Might be a little high.
Who's got that?
They're like 8.
That's closer. Good estimate.
Yeah.
49 squared is 7.
You got
7.2 sounds good enough. And so this value is 7.2. And so that is my displacement. And it's gonna be feet. Now here's the direction. XI, I point to where I finish. What direction? South,
Southeast.
okay. South, east. Alright? Good? Any questions? That's by far the trickiest that they get. The rest are pretty much like 1 through 6. Let's see, we have about 2 minutes. Try to do a couple, because we're gonna do a little activity tomorrow, and I just wanna make sure that you guys, like, we're gonna try to save a little bit of time so we have as much time tomorrow. So try a couple. It is not homework. Don't take it like where you have to finish it.